Assalamualaikum warahmatullahi wabarakatuh. My name is Afi Azman, and today I will present about the basic alternating current and its analysis. What is AC? AC is referring to alternating current, which is electric current that periodically reverses its direction. This is totally different with direct current that only can flow current in one direction. This current can change direction periodically, and the voltage in an AC circuit also periodically reverses because the current changes direction. Such example, it starts from 0, then grows to maximum, decreases to 0, reverse and reach to maximum in the opposite direction, returns again to the original value and repeats this cycle indefinitely. There are some comparison between alternating current and direct current. First, for alternating current, it is safe to transfer over long distance and can provide more power. For direct current, the voltage of the circuit cannot travel very far until it begins to lose energy. Second, for alternating current, it reverses the direction while flowing in the circuit. For direct current, it flows in a single direction in the circuit. Third, the current of magnitude varying with time. For direct current, the current of magnitude is constant. Lastly, for alternating current, the electrons keep switching directions which are forward and backward. For direct current, the electrons move steadily in one direction. What is sinusoid? Sinusoid is a signal that has the form of the sine or cosine function. It is based from the formula V equal to Vm sine omega t, where Vm the amplitude of the sinusoid, omega the angular frequency in radians per second, and omega t is the argument of the sinusoid. The sinusoids can be compared by using two ways, which are using trigonometric identities or using graphical approach. First method, trigonometric identities. The plots must both either sine or cosine function with positive amplitudes. The relationships as shown in the slide. By using that relationships, we can transform a sinusoid from sine to cosine form or cosine to sine form. For the second method, graphical approach, the conditions is still same with the trigonometric identities, which is plots must both either sine or cosine function with positive amplitudes. For example, cos omega t minus 90 degree equal to sine omega t. That means the direction of the arrow is 90 degree clockwise. What is phasor? Phasor is a complex number that represents the amplitude and phase of the sinusoid. It can be represented in three ways, which are rectangular form, polar form, and exponential form. For real axis, we present it with x. For imaginary axis, we represent it as y. To find r, it can be calculated such the square root of x square plus y square will give us the value of r. I have included an example about this topic, which is calculate the phase angle between V1 20 sine omega t positive 60 degree and V2 60 cos omega t negative 10 degree. State which sinusoid is leading. For this question, we list down the V first. After that, we convert the voltage V1 into cosine form to make it match with the V2 that have been stated in cosine form. We can use the relationship to solve this. After that, write the voltage V1 and V2 into phasor form. From here, we can know how much angle is difference between these two voltage. We can after the operation, we get that the difference between the two voltage is 20 degree. From the calculation, we can draw a graphic to make us more understand. So the conclusion is the voltage V1 lags the voltage V2 by 20 degree. So V1 lags V2 by 20 degree. What is impedance? Impedance is a measure of the total opposition that a circuit or part of a circuit presents to electric current. Impedance for passive element: resistance Z equal to R, capacitance Z equal to J omega L, inductance Z equal to 1 over J omega C. Impedance can be calculated in series and parallel. For series, Z equivalent equal to Z1 plus Z2 plus Z3, which is in series circuit. For parallel, Z equivalent equal to 1 over Z1 plus 1 over Z2 plus 1 over Z3, which is in parallel circuit. For example, given voltage source is 750 cos 5000 T positive 30 degree. Construct the phasor domain equivalent circuit and calculate the steady state current IT using the phasor method. The circuit as shown in the slide. First, we can find the impedance for inductance and the impedance for the capacitance. By using the formula given, just insert the information that we get into the formula. For the equivalent impedance, we use the formula Z equivalent equal to Z1 plus Z2 plus Z3. After that, by applying Ohm's law, we can get the answer. Lastly, for the steady state current, it gives us 5 cos 5000 T negative 23.13 degree ampere.